Newton's first law, aka the law of inertia. An object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an unbalanced force. Alright, ladies and gentlemen, this is an example of inertia. Dalton should really be wearing a helmet right now, but he's not. Whoa!
Newton's second law. The acceleration of an object depends on two variables, the force and mass.
Newton's third law, for every action there is an equal and opposite reaction.
This is an example of Newton's third law. Every action has an equal and opposite reaction. The action is that Dalton is pushing up on the weights. The reaction is that the weights are pushing down on Dalton. This is an example of frictional force because the gravel has friction on the tires. This is supportive force because the chairs are supporting Cody and Dalton.
I have two objects here. A piece of tape and a piece of cardboard. They weigh about the same. But when I drop these two, the tape hits the ground first because the tape has less air resistance than the cardboard does.
This is a spring force. It is caused by a compressed spring in the pen.
This is my weight on the moon. This is my weight on Earth. My weight on Earth is greater because the force of gravity is greater, not the scale.
This is a magnetic force because the forces attract each other. A nuclear force is what holds a proton and a neutron together in a nucleus. The marble continues to spin in a circle because of a centripetal force.
This is buoyant force because the water is pushing the ball up.
This rope is pulled tight. It is a tension force.
Hold my apron up.
If you rub a balloon against your hair, the balloon will steal electrons from your hair. This leaves your hair positively charged and the balloon negatively charged. Your hair will be attracted to the balloon because opposite charges attract. This is an electric force. This is an applied force. Peyton is putting the object in motion.
This is an example of Newton's third law.
There you go, ladies and gentlemen.
Hey, you ready?
Yep.
This is a frictional force.
Wait, no, when he comes in.
No, it just gets me.
On the moon. Now, this is my weight on Earth. This is my weight on the moon. My weight on the moon is less than it is on Earth because there's less gravity pulling me down on the moon. Now, on Earth, the gravity.
Hey, shut up!
Oh my God! This is my weight on Earth. My weight.
No, it's not.
Where? This is my weight on
Oh my god.
What?
You broke it.
Oh no.
Zero.
Okay, now this is my weight on the moon. My weight on the moon is less because there's less gravitational force pulling me down. My mass is still the same. My mass on Earth is greater because there's more gravitational force.
Should be your weight.
Okay. All right, here we go. Are we ready?
Andrew has
Yep.
to get on you.
I'm about to
Be quiet. You're not part of this group.
Yes, I am.
All right, here we go. Dalton, you should make bloopers. Hey, everyone be quiet. This is my mass